put a number 1 beside both of those, because that was our number 1 strategy to start with. We changed things to sine and cosine, and we got things to be a single fraction on both sides. So maybe I'll put, this is what I've been saying so many times. If you want to average at least 90% on all of your proofs, strategy 1 can get you to 90% overall almost every single time. But that doesn't mean that strategy 1 is going to be the best strategy. Okay? So some other things that can help you realize what's better, you should be aware of what's on the other side. Because looking at both sides and analyzing it a little bit sometimes can tell you, hey, there might be something better to use. And one of those things that's often better to use, and you recognize it if you look at both sides, are the Pythagorean identities. That's the sine squared theta plus cos squared theta equals 1, tan squared theta plus 1 equals secant squared theta, and cotangent squared theta plus 1 equals cosecant squared theta. And for those of you going on to take AP Calculus next year, all of these formulas are super important. You don't get a formula sheet next year. And having them memorized already also makes your identities unit that much easier. Today we're going to look at the advanced strategies. And I guess I'll put a little star. If you see a 1, I'll put a little red star by that one, sort of grouping things together. Because that's the Pythagorean identity again. But I am going to put an A with a circle beside these 3, because these are going to be some advanced strategies that we're looking at today, and then you'll be able to attempt any proof. This is going to be our first proof that for sure we're going to need to use an advanced strategy. Because if we think back to our basic strategies, if we go back to our strategy list, basic strategies numbers 1, change to sine and cosine, and have a single fraction on both sides. But if we look at this question, here it is, it's already in sine and cosine. There's nothing we can change there. And we don't have sine squared and we don't have cos squared, so we are not allowed to use sine squared plus cos squared equals 1, because that only happens if you have it squared. Second, okay, everything's in sine and cosine already. Let's make both sides a single fraction. But this is already a single fraction. And this is already a single fraction. So we are legitimately stuck at this point. Okay? Because our main strategies would not let us start anywhere. So in this question, I am going to introduce you to one strategy that has 2 different names. Okay? There's the name that I gave it. The name that I give it is build the other side. And the reason I came up with this name is because students remembered this strategy when it was written like this, as opposed to its main way that it's called. The main strategy, how it used to be called, or what it is described as, is multiply by the conjugate. Okay? So now we're going to have a test. Okay? This test will make your mark go up 10% or down 10%. can you define conjugate in mathematics? Would you want to take that test right now? No. Okay, this is why, yeah. Here's a mathematical word that most of us completely forget and have, like, if it was like on a test right now, really stressful situation, here you go. Your marks are either going to go up 10% or down 10%. Do you know what a conjugate is in math? And my experience is over time, no, we forget. It's not a word. It's not like you're going down the hallway and you're like, oh, how are you doing today? Have you been working with conjugates? Yeah, I've been, it's not something that we use very often. So, we're going to talk about it as build the other side. In mathematics, a conjugate is a binomial where one has a plus, then the conjugate is the same thing with the minus. A difference of squares is made up of two conjugates. Okay? But we don't use the word very often, and it's very easy to forget. And I also find if you don't know a word in a strategy, you also probably won't know the strategy, because you can't get past the fact that you can't even say the strategy because you can't remember a word. So I use this name of build the other side. If you're in this situation, and this is not a strategy you use right away, you should use your basic strategies first. But we're in a situation where it's already in sine and cosine. It's already, oh man, thank you for noticing. Volume's been off for a little bit. It's already in sine and cosine. And it's already a single fraction. So, what does it mean to build the other side? Well, we try to make something the same. And in this case, I'm going to build the denominators to be the same. These fractions don't equal each other, but you are always allowed, maybe I'll make a note of this. And this may seem silly when we look at it on its own. You're always allowed to multiply by 1. Right? You've got an answer. You can multiply by 1, and it's still the same answer. It seems kind of silly, but it's a key strategy in mathematics. And by multiplying by 1, 1 can look like a lot of different things. 3 divided by 3 is 1. 17 divided by 17 is 1. So I'm allowed to multiply by 1, and by building the other side, I'm going to decide I'm going to make my denominators the same. Right now, this side has a denominator of 1 plus cos theta. This side has a denominator of sine theta. So on this side, I say, I want a 1 plus cos theta on the bottom, but if I do that, I have to multiply the top by 1 plus cos theta, because then I'm multiplying by 1. And on this side, if I want the bottoms to be the same, I'm going to multiply this side by sine theta on the bottom, but if I multiply that by sine theta on the bottom, I have to multiply by sine theta on the top. And so what my strategy is at this point, and I'm not even going to multiply out the bottom, I'm going to leave it factored. My strategy is at least I have my denominators the same on both sides. And then I'm going to see what happens in my numerators. Maybe something nice is going to happen. Well, this right side is probably easier. Sine theta times sine theta. That's sine squared theta. And on the top, we have conjugates multiply by each other. We have to be able to recognize differences of squares. 1 plus cos theta, 1 minus cos theta. That's the factored form of 1 minus cos squared theta. And so by building the other sides, we now have our denominators the same. And so now, aware of both sides, all we have to do is figure out, is there a way we can make our numerators the same? Well, now I have squares. Now I can go to my Pythagorean triplets. 1 minus cos squared, that's equal to sine squared. And our left side is equal to our right side. and we're done our proof. So what initially seemed impossible, when we used build the other side, it became possible. Excellent. Right? Format-wise, we always start by rewriting what we want to prove and then drawing a line at our equal sign. Okay. I see cosecant squared. I take a look at my proof before I start, because just getting an overall picture of which strategy I may want to try or not want to try is important, because some strategies will be fast to prove and some slow. Neither are wrong, but you're probably thinking you would like to do the fastest way every time. So you have to take a little bit of time to look at something to see if there's a fastest way. So when I see cosecant squared, I'm like, hey, I know that's one of my Pythagorean triplets. I could change it to cotangent squared theta plus 1. Do I have cotangent on my left side? No. So I maybe would be hesitant to do that. I would also say, generally, we should be hesitant to change things like a cosecant squared to cotangent squared theta plus 1, because you see that the left side here is bigger. There's more things than the right-hand side. So usually when we have less things, things are simpler. So sometimes we should be hesitant to make something bigger because it might take longer. So after doing my initial examination of this one, I decide I think I just want to go with my number one strategy first to see where things go. So my number one strategy says change to sine and cosine and get a single fraction on both sides. Now there's a common mistake that happens on the right-hand side. So I want you to change that to sine on your own first, or off to the side if you're worried you're going to make the mistake. So I want you to change this side to sine squared. On this side, if I want to add fractions, I need a common denominator. So I'm going to get ready to multiply by 1. So I'd have to multiply that by 1 plus cos theta and 1 plus cos theta. And this one, I'd have to multiply by 1 minus cos theta and 1 minus cos theta. If you multiply the top and the bottom by the same thing, then you're multiplying by 1. Okay. So what does that do? Well, that will give me a common denominator of 1 plus cos theta, 1 minus cos theta. And on the top, this one gets multiplied by 1, so I'd have 1 plus cos theta, plus, and this one would have 1 minus cos theta. In the green box, I'm going to put the two options that students write after this step, okay, with the cosecant squared. I asked you to change it to sine squared. You know that cosecant squared theta is 1 over sine squared theta. Okay? The problem that happens here with students is what to do with the 2. And some students write it like this, and some students write it like this. So I want you to look at which one you wrote and which one you thought of, okay? Because one of them is right and one of them is wrong, right? And it doesn't matter if I showed you the right way right now, whichever way you're thinking right now is the way you're going to do it on the test. Even if I showed you the right way, if your initial thought right now is the wrong way, you would still do that on the test, even if you saw the right way. Okay, so we need to realize when we're making those mistakes. do we realize what is the right strategy? If we take our time. And by taking our time, do you notice that this is 2 times cosecant squared? So I'm going to just take my time and do 2 times and change my cosecant squared and take an extra step and do 1 over sine squared. We make our mistakes sometimes when we do too much at once. Try to do too much mental math at once. Okay? Then we are multiplying this 2 out front is multiplying fractions. It's 2 over 1. How do we multiply fractions? We multiply the tops and we multiply the bottoms. So now looking at the 2 options, the temptation is to move that 2 down to the bottom with the sign, but that is actually wrong. And we can see that it's wrong if we take our time and change it. Okay. Now, on the left-hand side, I got a single fraction. I can do some simplifications here. I hope you see that 1 plus 1 is 2 in the cos, the minus cos. They cancel out. On the bottom, I have a difference of squares. And so I used my main strategy. I changed things to sine and cosine. I got a single fraction on both sides. And now I'm very close. Okay? Now I look at both sides. I notice my numerators are already the same. Things are good. So then I really look at my denominators because they're going to really give you a hint. Can you change 1 minus cos squared theta to sine squared theta? Absolutely. So I'm going to do that. That's a Pythagorean triplet. Therefore, our left side equals our right side. And we are done. Questions to circle on this one? Our 4, don't. Just 12, 8.